Welcome. Let us take a look at number 2. The number of calories in a 12-ounce serving of randomly selected light and regular beers is listed. We will test the claim that the mean number of calories in regular beers is greater than the mean number of calories in light beers. So we have population 1 and population 2. So there's a random sample here of 10 regular beers and 8 light beers. So when we're given the data, the first step is to enter that data in our calculator. So I've done that already. If you'd like to pause and enter your regular beer calories in L1 and your light beer calories in L2. And then we'll move forward to our hypotheses. So I'm going to put the claim here first. So we're testing the claim that the population mean calories in all regular beers is greater than the population mean calories in light beers. So our null hypothesis will be that those means are actually the same. So I'd like to find actually the sample means in these cases. So we're using samples to draw conclusions about the populations. So let's go ahead and do 1var stats. So stat, calculate 1var stat. And if we don't put anything after 1var stats, by default, it looks in L1 and tells me that the average for those regular beers in the sample was 125.5 calories. And then I'll do my L2. So stat, calculate 1var stats. And now second 2 to get my L2 there. And then the calculator will give me that sample mean. So that came out to be 111 calories in the light beers. So we're going to look at the difference between those. So 125.5 minus 111 is a difference of 14.5 calories. All right, 14.5. Okay, so let's find the test value corresponding to that difference. So we'll be drawing a graph of this hypothesis test at the bottom shortly, but let's go ahead and get the information in total first. So we are not given the standard deviations of the populations. So we know we're doing a 2-sample t-test, and I'll just make a note of that up here, that sigma 1 and sigma 2, the population standard deviations are unknown to us. They were not provided, so we know we're running a 2-sample t-test. So stat tests, 2-sample t. And now because we actually have the data, we change our input to data. If it's not there already, the lists will be L1, L2, frequencies will be 1. And then our claim here, mu1 greater than mu2, or right tail test, pooled is no. And I'll go ahead and do calculate. And there's our test value or test statistic t. We'll round it to 3 places as usual for our t scores, our t values, 2.194. And our p-value 0.0217 or 2.17%. All right, so to determine if our findings here are significant, we're going to compare it to an alpha significance level of 1%. So comparing our p-value to an alpha of 1%, our p-value is greater. So we do not reject our null hypothesis. So based on this sample of 10 regular beers and 8 light beers, if we're using a 1% significance level, there is not enough evidence to support the claim that the population mean number of calories in regular beers is greater than the population mean number of calories in light beers. All right, so before I do my part F here, I'm just going to go to the bottom so you can see the visual here of what we're doing. So as always, with hypothesis testing, we assume the null hypothesis is true at the start, and then we decide if we'll be rejecting it. So remember, the null hypothesis was that the means were equal. So if the means were equal, the difference between them would be 0. So if the difference between them were 0, if the means were equal, then most of the time, if I took samples of regular and light beers and looked at the difference, you should be getting a difference close to 0 if the null hypothesis is true. All right, but what did we get for our data? I'm going to put the 0 in the center there. For our data, T came out to be over here. That test value was what was it over there on the calculator? 2.194. And what that told me is that my difference here, we got 14.5 calories as a difference. So that's getting pretty far away from 0 to the right here. And that area to the right of my test value is the p-value. And that was 2.17%. So we have to decide if our 14.5 calorie difference is far enough from 0 to cause us to reject the null hypothesis. Well, at a 1% significance level, we did not reject the null hypothesis. But now let me go ahead and take a look at my part F here. So the significance level sets the threshold for determining if sample results are statistically significant. So results are statistically significant if they lead us to reject the null. So what if for our study, we had decided instead of using 1% alpha, we went with 5%. So what would change here? Well, the p-value would still be 2.17%, but now we're comparing it to a threshold of 5% for alpha. So now our p-value is less than or equal to our alpha, which would lead us to reject the null hypothesis, indicating we do have significant sample data. So based on these 10 regular beers and 8 light beers, if we go with a 5% significance level, we would say that there is enough evidence to support a claim that the population mean for regular beers is greater than that for light beers. So to summarize here then, we've drawn a conclusion about the populations of beers based only on samples. In other words, we've made an inference. So when we make an inference, use samples to draw conclusions about populations, it is always possible to be incorrect because samples are not perfect pictures of an entire population. So the type 1 type of error that could be made, a type 1 error occurs if we reject the null hypothesis, as I just did here, when in reality, the null hypothesis were true. So the probability of making what's called a type 1 error is the value that is selected for alpha. So we rejected this null hypothesis at a 5% significance level. It is possible we made a mistake and that the means truly are equal. And the probability of making that mistake is 5%. All right, and that wraps up our 2-sample t-test.